Hi, everyone. My name is Jimena. I am Global Manager of Statistical Forecasting at inBev. And before we start, I just wanted to give you a bit of background on myself. So basically, I started my career at British American Tobacco in divisions of trade marketing and sales. And then I moved to what I really love doing, which was demand planning. I spent 8 really amazing years at British American Tobacco, and then I did my master's in data science here in London, where I learned the state-of-the-art algorithms in order to be better at forecasting volume of the different companies that I could, potentially join. And then I took a slight turn in my career. I decided to go into consultancy, so I spent 3 years at EY building models, basically, to answer business questions for different companies. That was really fun stuff, because I was actually using advanced analytics to do that, so it introduced me to a different world. But then it was time for me to go back to the consumer goods industry and to go back to what I really love doing, which was demand planning. So I joined ABI 3 years ago, and I joined the demand planning division as Global Manager of Statistical Forecasting, as I said. And the reason why I wanted to just quickly walk you through my journey is because I think it ties up really well with what I want to talk to you about today, which is how do we leverage AI and machine learning into demand planning. 15 years ago, when I started my career, AI was not a buzzword in demand planning, especially in the consumer goods industry. And 3 years ago, I rejoined the industry, and it had completely changed. And it definitely opened my eyes to how much we've evolved and how our processes in demand planning have embraced AI and how they will continue to change to continue to embrace it. So let's start our presentation today. As I said, leveraging AI and machine learning in demand planning. So just a quick glance through our agenda. I want to start by walking you to the best-in-class models for consumers goods industry. There's a lot of buzz about AI, and it predicts our volumes, and it does a great job at it, but what's really behind it? Then I would like to walk you through how we are redesigning demand planning in order to unlock the benefits of AI. And then I would like to show you some of the models, 2 really good models that we've implemented in ABI that have allowed us to optimize our enrichment capabilities. And lastly, I would like to share with you some of my thoughts on the role of the demand planner of the future. So today, we have so many different models that we can use to forecast ourselves. But which one to choose? So we can, I think we can categorize the different models that we have out there into 2. One is univariate models, and the second is multivariate, or the famous machine learning models. So I won't bore you with the geeky side that is behind each one of these models. But the best way of thinking of univariate models is think about a solo piano player. The best way, perhaps, that we would have to predict the next genre that he will perform is by listening to the notes that he's been playing during that concert. With multivariate models, it's slightly different. Think about an orchestra. An orchestra where each musician is giving you a different piece, a different note that might help you infer what the next song is going to be performed in that concert. So this is just, something very simple for us to help us understand what the models that we may use to forecast ourselves. But we're still left with the question, which one to choose? So there are different recipes, but the most important thing is to let your data speak. So these are some, I wanted to bring some for very basic generalizations that we have in data science. So if your cells exhibit clear patterns, then you may want to choose like an ARIMA or an exponential smoothing model. They're very easy to deploy. You don't need a lot of investment. Sometimes you can deploy it in Excel. So you may want to think about that before investing into something really big. If you have, like us in the beer industry, complex relationships in the variables that may impact your cells, you may want to opt for machine learning models like random forest, XGBoost, or even more advanced techniques like neural networks. In our case, price and promo plays a big role. So we play a lot with elasticity, so for us that's very important, so we need this type of models. For large data sets, if you have big data, and not only numerical data, but categorical data, then you have CatBoost models or XGBoost models that are really good at that. And finally, if explainability is a must for you, then you're left with not a lot of choices, so you may just need to opt for a linear regression model. So, a lot of maths, but let's go back to the main question. Which one to choose? Our recommendation, what we do at ABI, is we don't choose like one, we choose all of them. So something that we use, and it's now become a best practice in terms of stats for us, is something that is called a hybrid approach. So think of a hybrid approach like the same way you would think about a weighted average. So a hybrid is basically a weighted average of all your models, both univariate and multivariate, where the weight is basically given according to the performance of a specific model in your cells. So the better a model is at predicting your cells, the bigger weight it will have, and you will benefit from all of them. So now I've told you what works for us, and hopefully it will give you some food for thought. But how does that, like all of these models that we now have and are able to use, have reshaped our demand plan processes? So I remember 10 years ago, when I was working in demand planning at British American Tobacco. I would sit down with my boss, and we would basically open a spreadsheet and define what we were going to sell for the upcoming 12 months in a spreadsheet, basically. So I'm going to walk you through kind of what the process was like. You should know all about it. So I would download my data, my sales history. I would do some normalization. So I would probably, for example, there could be price speculation in the market. So I would know that the spike that I'm seeing in sales is really not organic. So I would probably, chop that out of my sales and cleanse it. And then I would know what's going to happen next, what events might move my volume, like Carnival in Brazil. So I might just put an uplift in my predictions for the upcoming month. And that finally would give me a baseline. But that was not the end of the journey. I would also start talking with my brand managers. I would want to know what innovations are we launching, what promotions might move my mix, so that I would do further adjustments to my forecast. And then finally, I would take a look at any external events that might be impacting me. In the tobacco industry back in the day, illicit trade was a big issue, and I knew it had a direct impact on my volume. So I would just have a look at that, and then after applying some adjustments, I would be happy, and I would release my unconstrained plan. So as you can see, this old school demand planning was very Excel-driven, and also it relied a lot on commercial assumptions. And not only that, it was really hard to get those commercial assumptions. It meant like a lot of chasing to brand teams, to trade marketing teams. So there was a lot going on in that cycle. But how is it now? How do I see it now that 3 years ago where I rejoined the industry and I saw a demand planning process, leveraging AI. So now, basically, our models would be connected directly to our cells. They would also do normalizations or correct our history based on perhaps the standard deviations that we've set up and some automatic rules that we know are necessary for our regular cleansing. We would also directly connect our internal drivers to our models, such as data sets of price and promo that are being curated on a weekly or monthly basis by our planners. We would also connect them automatically to external drivers, such as weather and macroeconomic data that are continuously being fed to this model. And then, magically, I would have a statistical forecast, which would be my baseline. So me as a planner, now I would walk in on a Monday, and then magically would open my laptop and have a statistical forecast ready for me to use. But do I do that? No, because I still need some commercial insights. So what I would focus my time on is on commercial collaboration, in making sure I get the best signals from commercial that I can, so I can impact positively my plan and finally release it. So now, the demand plan process, you can see, it's very stats-driven. It allows us to have an unbiased baseline as a first step, and it allows the planner to focus on enriching the baseline in a strategic way. So, but new processes come with new KPIs. So before, I used to have one forecast accuracy, the demand plan forecast accuracy, which was the one that I released. In ABI, we actually track three things, three KPIs. One is the stats forecast accuracy. And the second is the demand plan forecast accuracy, which is the accuracy of the plan after the enrichment, and the value add, which means we want to understand how much value the enrichment from commercial is adding to the company. And why? Why go through all of this trouble? Well, three reasons. We found ourselves in the need of driving change management. Not everyone, I've been a planner, I would have struggled to trust stats, if somebody would just deploy them and say oh, now this is what you use. So we needed to put some hardcore numbers in front of them. Then the second reason is we need to ensure strategic enrichment. Nowadays, it's important that we focus our time in enriching our strategic or our products, the products that are most important to us. And thirdly, we want to maximize value add. We want to make sure that the insights that we put on top of the baseline are adding value to the supply chain. But what happened? What is it that, what was the situation that we found ourselves in when we started deploying this and tracking all of these KPIs? So what we found was that between 50 to 70% of our volume forecast was being deteriorated by commercial enrichment. So what you're seeing here are three of our key markets. And the red areas of the pies show us the proportion of our forecast that was being deteriorated by commercial enrichment. So this for the supply chain is super disruptive, even though if you see in key market 2, overall, their value add was positive. So commercial was actually very happy, oh my God, we're adding value. But you're adding value to the, basically you're adding value at the cost of adding value to 43% of the volume, but subtracting value from 57% of the volume. So for the supply chain, we know that that doesn't really work. So what do we do? We created two models, two techniques to support planners in optimizing their enrichment capabilities, touchless and segmentation. So two of the main challenges that we had for our planners to adopt AI, to adopt the stats, was first the trust. Commercial didn't trust that what the stats were predicting was correct. And then also, we had old processes that were not supporting this new input. So we created, as I said, two tools, segmentation and touchless. So what are they? Segmentation basically tags the strategic importance of a product according to the volume and volatility that this has. As a supporting tool, we have a global internal toolkit that basically takes the cells from each market and then automatically tags what products are, have like specific segmentation. And I will show you what I mean by that. The second tool we have is touchless. So what is touchless? Touchless are products or demand intersections that should not be enriched or touched, given the poor enrichment capabilities that we've had at enriching those products in the past. The supporting tool that we use is a probabilistic model that the planners run every week that tags automatically the likelihood that we have to damage through enrichment a specific product. So this is roughly what segmentation for us in ABA looks like. So we have 4 different segments for products. Horses, it's the products that for us are really big in volume and very steady in terms of volatility. So they're they don't have like much of a trend really. So it's really easy for the stats to forecast that. So we ask planners not to enrich these type of products because the stats probably do a better job at that. The second segment that we have are mat pools. These are products of big volume, but have like a lot of volatility. So the stats are not going to be very good at predicting their forecasts. So this is where we want to capture the intelligence from commercial to be better at predicting the sales of these products. Then the third segment we call mules. These are low volume products with not a lot of volatility. So we really just want to rely on the forecast. It's probably it's good quality, and also the volume is less, so why not? And then finally, we have what we call jackrabbits. Jackrabbits, you can think about it, jumping rabbit. It's a low volume product with a lot of volatility. So our forecast probably is not really good at it. However, should you spend time in enriching products that are so low in volume with such high volatility that you might not even be able to predict it? And the answer is no. We don't want our planners wasting time here. So these are kind of the very generic rules that we deployed for planners to approach enrichment, given the strategic importance of a product. And this is just a glance at our touchless probabilistic tool. So what you're seeing here is a distribution of the demand intersections for a market. And in the x-axis, you are seeing what we call an enrichment capability index. So here's, we have 19 weeks of data. So our indexes go from -19 to +19. So the more negative an index becomes, means that you have harmed the product through enrichments more time than you have added value. So what you want to do, you want to stop enriching the most negative of your indexes. So what happened when we started deploying this model? At first, it was a negotiation process. It was, okay, the planners were, okay, I see your point. I'm going to stop touching perhaps the most negative index from -15 to -19. Okay, fair enough, it's a starting point. But then it really started to make a positive impact for the planners in terms of forecast accuracy, and it helped them achieve their targets. So then they became really aggressive, and they were like, I'm not going to touch anything that have that has a negative index. To the point that now some of our biggest markets are afraid to touch anything that has a negative index, allowing for publishing of plans with 80% of our volume going touchless. So just wanted to show you a use case of this. This one was one of the first countries where we deployed this with great success. So if you see the red dotted line, this shows us the proportion of cells with negative value add that a market was having. So if you can see it, it's around like 70% of our volume forecast was being like impacted in a negative way. And the green line is the forecast accuracy of the stats, and the blue line is the forecast accuracy of the demand plan. If you see, there's a lot of gap, and the stats were always like consistently better, but we were still reluctant to use them. So after deploying the probabilistic tool and a lot of negotiation, we finally got the country to where we needed to. So if you see now, like after touchless begins, our stats, not only they became better, but the proportion of cells impacted by negative value add decreased dramatically. So now we have a market that publishes 50% of their volume as touchless, which means that we've gained a lot for the supply chain in terms of savings, better inventory policies, and we've been able to deploy this in every market of ABI. So we're very happy with where we got. So I've shown you a bit of what we have in terms of models, how we've supported planners to embrace it. So what does that mean for the role of the demand planner of the future? So we believe that demand planning of the future will rely on demand planners working closely with data scientists to add value to the supply chain. So let's just go a bit into the role of a demand planner and a data scientist, who is the new player in demand planning. So our demand planner will still be key at delivering the demand plan cycle, from demand review to SNOE, SNOP, etc. They will still need to run it, and we believe that they will manage it better with all of these, with AI enabling better processes. Something new that we believe the demand planner will add to their to-do list is the curation of relevant data sets. What do I mean by this? For example, the planner of Brazil, they may want to curate a data set for the FIFA World Cup because it kind of drives the country during those years. We need to be better at curating price and promo. We need our planners to know what data can be ingested by our models in a successful way. We also believe that demand planners will run our statistical tools. They will, and by running, I mean they will be the master users of any statistical tools that we may deploy. They will be able to click a button, run it, drill on whatever they need to drill, be able to really, extract value in, unthinkable ways from the platform. And then finally, we believe planners will play a bigger role at enriching at a mid and long-term horizons. Why? Because machine learning might not be as good at predicting what's going to happen 5 years from now than planners might be. It might be that I know as a planner that we'll have 2 more breweries. Okay, that the model may not know. So that would be the demand planner role. But what is the data scientist role? Who is the new player in town? So the data scientist will be in charge of algorithm continuous improvement. So our models will always need some maintenance. They will always need, things as parameter tunings. And machine learning is an ever-changing field. So you want data scientists to always be, bringing the best things to your deployed models. also, they will be in charge of embedding the drivers that planners curate for them in an innovative way. So it might be the case that your market has sellout data. And a data scientist might take your data and say, well, we may not just want to plug it into the model. We may want to, develop some tests to see how the model reacts if we take lags. Those are innovative ways of engineering features for the models that are important. Then data scientists will identify best practices. We have a team of data scientists working on continuous improvement across our key markets, and we've been able to identify 6 best practices in terms of stats that work almost everywhere where we deploy them. And finally, data scientists will be in charge of designing enhancements according to planners' feedback. We still believe that planners hold the true knowledge of the market. So we pay attention to what they have to say, what their feedback is, and we try to transform that into a stats enhancement. So we believe that's where the collaboration between these 2 players will add value to your operation. So that is, after speaking so much, just let me try and summarize some of the things that we've seen. So incorporate hybrid models to your forecast. Why choose from so many models if you can have them all? To really harness the power of AI models, you need to redesign your demand planning processes. That, I think, is crystal clear for everyone. Strategic enrichment becomes crucial once you deploy AI. So you need to have a framework for segmentation of your products. And then something that we've discovered, there's a high likelihood that commercial enrichment might deteriorate your forecast accuracy. So you want to support your planners by creating tools that allow them to identify where stats are better and where they should go touchless in terms of forecast. And finally, the roles of our planners will change with AI. And we need to understand what's the best way to reshape them. But we still believe they're going to be key players. So it's an ongoing learning for us. So I encourage you to keep on, thinking and designing their roles. And that was it for me. Any questions? If not, then I'm happy to take them afterwards. I think they... Thank you.
One of the key, we've gone through a very similar exercise quite recently over the last few years in terms of embracing the statistical forecast. One of the key obstacles that has been is actually relinquishing control from the commercial side of things and getting them away from questioning how a statistical forecast, even though you can bring those tools in through forecast value add and demonstrate exactly a proven history of statistical forecasting outperforming the market view of things. How did AB InBev go around to kind of get the commercial side of things to relinquish that and not go wanting to know exactly how, what you said through the linear regression modeling, through those different drivers? Is that still a journey you're going on, or was there kind of buy-in to say, if it's with those touchless rules that you've introduced, we as a company are going to say that's what we adopt, and rather than interrogating every single aspect of how the forecast was derived? How does that process go with the commercial team?
Yes. So touchless has been a success at the short-term forecast release. By shortcuts, I mean we pay a lot of attention to our week plus 2 forecast accuracy, so what we're going to sell 2 weeks from now. So that's where touchless has played a crucial role. So for us to move commercial, not away, but to convince them and gain their trust, we developed this probabilistic tool. But at first, when I joined the company, it was so like, oh, look at the stats are better, but maybe they were better 1 week, maybe the other one, they were as good as the demand plan. So we had to go to the exact level of granularity that they use to publish the forecast in order to speak the same language. So I believe like demand planners are, like they work 120% of their time, like they already stretch. So if you give them something that is not immediately consumable, it will be very hard for them to like get to where you need them to be. So what we developed was almost like, these are the intersections you publish, these are the intersections, you just, whatever you want to enrich it with, like just copy and paste stats. Literally, we had to get to that level for them to actually, like, to meet them halfway. Because there was some willingness, but we were lacking a specific, like, tool to get there. So at short term, touchless played that role. It took us a lot of convincing. I think it took us like a year of working with all of, first we started with our key markets, around 42% of our volume, it's concentrated on those. Once we had successful cases there, we started deploying everywhere. But the long-term forecast, that's where commercial, like, we see it plays a good role. We haven't released this probabilistic tool for the long term. It would be interesting to understand, the stage that make a diagnosis of the enrichment for the long term. But so that way commercial doesn't feel like they're so like out of the table. They're still there, but focusing perhaps on the long term, which is where I really want them to, not the short term where everything has been said really at that point. So hopefully that answers your question. I'm happy to discuss further.
My questions, to be fair, but going back to the sort of art and science and where you did demand planner and data scientist, just more on the structure, the way you did it, did you guys centralize the data science because you had like 6 rules that work for most markets?
Yes.
Or was it something that you do market by market, you have data scientists in each market? How did you sort of spread those roles?
So I have a team of data scientists, 4 data scientists and 2 functional consultants. So the way that we've been working so far is we are using O9, so we deployed O9 in all of our markets. So we have like a standard deployment of univariate and machine learning models in every country. So what my team does is they go to a market, they see the models, and they say like, oh, I think this might work, I think this may not work, and they design their enhancements. So it's been 3 years of learning, and we've tackled, I think, like 8, 9 markets. And from the learnings of those markets, we've identified 6 things that have worked, because whatever worked, I don't know, in Canada, we tried for Brazil, it worked, and whatever worked with Brazil, oh, maybe this will work for Canada, and then it's been that kind of journey. Now we're going really, really big with continuous improvement in terms of stat. I have in my pipeline 15 markets, so that's gonna be quite a challenge for my team this year, but the idea is like, we've identified things that work for our products. Let's dream big, let's try to deploy it. And what I love about ABI is like, if we fail fast. So I don't think we will, but why not dream big if we can? But that's the way that we've designed it. We have a specific team of data scientists working on continuous improvement for specific countries according to the company's agenda.
Third one. Super cool presentation. Thank you. Really enjoyed it. The question I have is around consistency or stability of the stat. So obviously the forecast is used as an input to a plan. Did you have any challenges around the stability or the consistency of your forecast creation cycle over cycle?
Yes. I wouldn't say it's an ongoing battle. I think at first it was. I think one of our go-live criteria one of our go-live criteria for a market is stability. So before you have the market using that forecast, you want to sign off on that. That's one check. But obviously, after gone live, a million things can happen and stability might go on and off. I think what I've seen is in markets where we have a hybrid model, because you're averaging everything, that just gets, like, that risk gets mitigated. But we definitely have markets where, because the best fit criteria might be designed to choose a champion model. I don't know, 1 week you may have Cat Boost as a champion. The next one, it might be simple, moving average. In those scenarios, what we've said is like, okay, let's not change the champion model like every week. Let's just do it every 3 months. So you provide some stability, but that's kind of like the things that we've seen.
Really, really interesting. And yeah, looking after a demand planning team as well as others, it's very interesting to hear how you've done this. I think one of the main questions for me is the touchless, which is something that we're striving for because we see the benefit in it. When you talk short term and long term, what are those horizons?
So short term would be the upcoming 13 weeks, and then long term would be anything beyond that. I'm a bit radical with touchless. I would like to see touchless for the next 12 months, but baby steps. So, but yeah, that's kind of how we approach it. All right. Well,
Thank you. Yeah, just like everyone else, a really interesting presentation. Thank you. Very much myself as sort of an amateur in this, so a very, I guess, basic question for me. Are you talking about the planner, the data scientist, and different models? Just I guess the big news at the moment, which everyone focuses on, is these large language models with GPT-4, GPT-5, 6, I'm sure coming down the road. Just in terms of what you see on the coalface, what's your view in terms of how these models are enhancing what you're doing or disrupting what you're doing between the planner and the data scientist, or enhancing what you're doing? Thank you.
So if I think about how data scientists interact with demand planners, I don't think there's a lot of disruption in terms of the processes. Like, we've set up like continuous improvement routines on a bi-weekly basis. In the markets where we work, continuous improvement. And processes for planners do not change. Like, I hate put more burden on the planners because they run our operation in the cycle. So what they go into these meetings they come in with hypotheses based on what they see on their day-to-day. A hypothesis can be, in our country, weather does not play a role. So we believe the weather drivers that might be causing us to under-forecast. It's a hypothesis. So our data scientists may decide to test it or not. Why do I say may? Because there are also planners that, because we're still in this journey where they're starting to interact, the two roles, we need to improve the quality of the feedback. I have planners come into these meetings like, seasonality is wrong. The model has no seasonality. It's like, okay, I know that's not true. And mathematically, it can't be possible. And also, there are some check and balances that we may just do on the fly to prove or disprove it. So you want to put a filter also into the noise that could come from planners. So that's kind of how I see their two roles, like the planners giving feedback to data scientists, and data scientists proving, disproving hypotheses. And whenever a hypothesis goes through the process that we've designed from feedback to deployment in production, the data scientist role almost becomes as the enabler to the feedback coming from the planners. So I see them interacting really well. It will be interesting to see how this becomes almost like an ongoing, like a more of a robust routine, and everywhere at the moment we've only done continuous improvement in specific countries. 5 years from now, that might be different. So I don't know if I answered your question, but that's kind of how I see the two roles, like adding value to each other, but also not disrupting their processes and deliverables as business as usual. Okay, well, thank you so much.